Okay, good morning. Good morning. Week 7, last class of week 7, and then 3 more weeks after that. So it's exciting, and we're getting to the places where we can do some cool stuff in C++, which is really nice. So I'm thinking what we'll do today is pick up the code that Jaden worked on. Hey, Jaden, you were here just a minute ago. When I said your name, you just disappeared, took off like that. All right. Okay, he's back, hopefully. Okay, all right. Welcome back, Jaden. I thought that as soon as I mentioned your name, you just took off. So I thought maybe, last class was a bit too much. But I was thinking we'll take your code, which you posted, and someone else today. I don't know, Kiki, you did code? Yes, in just a couple of classes you coded. Everybody here has coded. Jose, Kate, Tim, Jaden twice, Anthony has coded. Well, you know what? It's only 8:03. We'll give people a chance to join. Ideally, someone who hasn't coded before can take the chance. If nobody else picks it up, you guys, one of you, not Jaden, because he's got 2 chances now. So someone other than Jaden can pick up the code, and we can edit it. So I'm thinking, well, okay, here's what I was thinking this morning. We have 8, 9, 10, 11, right? So next week is week 8, 9, 10, 11. And then the topics we have to cover: searching. I'd like to do searching, right? Maybe a half a week at least. So we'll do searching next class, next week, right? How to search a collection of things, how to search that. Because it's one of the core problems of computer science. You got to do searching, no matter what complex, sophisticated algorithm you're doing. There's going to be some form of searching in there. Okay, so we'll do searching next class. And then after we do searching, the week after that, in week 9, we can do sorting, right? Sorting of elements. So if you have a list of elements, how do you sort it? And then week 10, we can talk about stacks. So you already know what a stack and a heap is in a system, right? Places where variables are stored. And so we'll talk about how we can implement our own stack, so we get a much better idea of how it all works inside of the computer. So we'll implement our own stack in week 10. Week 11, we'll talk about linked data structures. So I think it's the exact same plan that I followed last quarter. Every quarter there's a minor change, like this quarter, we started talking about objects in week 6 itself. We didn't wait until week 7, because last quarter, I think week 6, we didn't actually talk about objects because it was still midterm. And so we said we'll do other stuff, and then we started talking about objects in week 7. Still managed to cover it, but this time we started talking about objects in week 6 itself. So which means we can get more coverage of objects and then still manage to finish everything by week 12. So it's really cool. I'm excited for this. So I'm glad. I'm glad that you're all so engaged. I mean, all of you are here, who are here. You've all been so engaged and trying to solve these problems. And no matter where you are, or where you go to school, where you're studying right now, I think it's my personal opinion that if you just persevere and get through all 27 quests, blue, green, and red, you're pretty much set up to be a professional programmer at that point. Okay, so you can get a degree, pick up a degree on the side along the way, or pick up some extra skills that let you specialize in a particular area and things like that. But all of that will be super easy. After you finish quest 9 of red, everything will be super duper easy in programming. Not everything. You also got to be good at math, reasonably good at math, not like super duper expert. But you certainly need to know about variables real variables, meaning that not discrete. So in math, there's a very clear distinction between discrete variables and continuous variables. Are you guys familiar with that? Because I mean, these things will factor into computer science and everything else too, right? And also in science. Are you guys familiar with discrete variables and continuous variables? No. Wow. Okay. So do you want me to talk to you about that while we're waiting for the other people to come in? Yeah. Okay. So I think this will be super duper useful. Okay. So, and in fact, okay. So, and here, before I start talking about that, in wherever you're enrolled, okay, whether it's UCSB or Harvard or Foothill, any class, any institution, if you're in this class, look for a class that is titled discrete mathematics. Okay, it should be called discrete mathematics, and enroll in it. Okay, enroll in it. And it is going to be a fun class, and it is going to be so super important to computer science. Okay, and that'll teach you all about this. So, but where I'm going with that is that there are two kinds of variables in your programs too, right? You can use integer variables, and integer variables have fractional values? Right? Okay, no, right? So integer variables can only jump from 1 to 2, 3, 0, and so on and so forth, right? So if you look at the graph paper, and you draw lines where the integers are, right? So 1, 2, 3, and 1 likewise on the y-axis, right? So what do you get? You don't get a sheet of paper. You only get what is called a, you can call it like it's a lattice or a trellis, right? It's not the whole thing. It's only, you get these lines, right? So it's a lattice. And then where these lines intersect are called lattice points. So the lines will intersect at 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, yes. So can you visualize that? Okay. So, all right. So an integer variable that can only jump from lattice to lattice point, 1 to 2, 2 to 3, cannot take any intermediate values. That is called a discrete variable. Okay. Discrete variable means it cannot take fractional values. Okay, but I shouldn't say fractional, because real variable is even more than fractional. I'll come to that in a second. Okay, so this is being recorded. Yeah, it is being recorded. Okay, so I don't want to say the whole thing again later, but okay. So an integer variable is like that. Okay, so how many integer variables? How many integers are there? How many integers are there all together? Okay, all together, how many integers are there? Someone take a guess. Come on, it doesn't matter. Just feel free. You can say there's only 5 integers. That's also fine. Okay. And then all we have to, hey, hang on, just a sec. Why is hey, Google, connect to my Mac.
This device is already connected to McCann Foothill 545.
Hey, Jose, can
you disconnected?
Jose, can you say something again?
Yeah, can you hear me?
Well, wait a sec. No, Alexa, connect to my Mac.
Searching. Now connected to McCann Foothill 545.
Can you say something, Jose?
Can you hear me now?
545. Okay, Bubba. What day and time?
I didn't even ask for a day and time. Jose, can you say
Can you hear me now, Professor?
What day and time?
Why say, when I say Jose, say something, Alexa says what day and time.
Yeah.
What day and time?
Look, right? What did I say? What did I say? Jose, say something.
What day and time?
How does it? Is it even rhyming with what day and time? Say something.
Can you hear me now, Professor?
Yeah. Okay. I got to experiment with that later. Okay. Somehow Alexa is fitting that into what day and time. All right. Cool. Yeah. Well, so how many integers are there altogether?
I want to say 9.
Okay, well, so all right, so that's great, because what Jose said is a scientific theory. Okay, a scientific theory is an important theory that is only advanced by people of a scientific mindset. And what Jose just said demonstrates that he has a scientific mindset. What I mean by that is that it is okay to come up with a wrong answer, as long as there is a very good likelihood, or even you make it possible for other people to test it and say, no, here's a counterexample. Okay, so Jose said there's only 9 integers, which means he knows that other people can say, well, you know what, I got a number called 10, and it's not in one of your sets. It's not in 1 to 9. Therefore, your theory is wrong, right? So there's got to be more than 9 integers. Yes. So does that make sense? So that is the hallmark of a scientific theory, okay? As opposed to saying there's a whole bunch of integers, okay? And then someone says, how many, right? There's a whole bunch. You can prove it or disprove it, right? It's like a hand wavy theory. So that's not a scientific theory. But saying there's only 9 integers, there's only 9 planets in the solar system, okay? That's a scientific theory, because someone can say, no, I got evidence that can disprove it. Okay, so we've disproved the fact using a counter example that there are more than 9 integers. Okay, so someone take another guess. Say how many integers there are altogether.
When you say how many number of integers, it's like this is also like including the factor of like data representation, because I get the
No,
number
nothing to do with computer science here. Okay, no computer science. It's only mathematics. We'll eventually factor into computer science, only mathematics. How many numbers are there altogether? How many integers? I mean, if you had to write down all the biggest number, what is the biggest number you'll write? That is the number of integers, right? So what is the total number of integers that are ever there? Forget about what you can write and things like that. In your mind, what is the biggest number you can conceive of in your mind? Right? Or even, what is the biggest number that is out there? Even things that you cannot conceive of. What is the biggest number out there? How many numbers are there?
Would that be infinite?
Infinite, thank you. That's what I was looking for, Tim. All right. So there's an infinite number of integers, yes? Because you can go 1, 2, 3, 4, all the way up to infinity. Okay, so it's an infinite number of integers. So now if someone tells you, well, you know what, there is a number that is bigger than infinity, right? Meaning that you've got an infinite number of numbers, but I've got another set of things here. This has more than this bag of all possible numbers. Can you prove? Is it possible to prove that? Is it possible to prove that? Or take something easier. Okay, so now 1, 2, 3, 4, all the way up to infinity. That's an infinite number of numbers. Yes, that's in a bag. Now someone else comes up with another bag and says, I have a whole bunch of integers here, but these are all even integers. Okay, no odd integers, only even integers. 2, 4, 6, 8, 0, 2, 4, 6, 8, and so on up to infinity. So how many even integers are there? Infinite, right? Because if it is infinite numbers, you got infinite even integers too. Now, this is a bag of even integers. This is a bag of all possible integers. Now, can we say that these two bags, can you rank these two bags by size? Is one bag bigger than the other? Well, it seems intuitive to say, all numbers definitely bigger than all even numbers. Yes? Yes or no? Yeah, because this only has even numbers. This has all numbers, including odd numbers. However, you can prove mathematically that they're exactly the same size. Meaning that for every even number you give me, I can give you a different natural number. Okay, so for every number you give me, I get to give you a different one, and I can do that infinitely. And so that means I can give you a 1-to-1, right? I can marry off each one of the even numbers with a different number, right? Different one. So no even number has 2 partners, and no number has 2 even partners. Okay, so everything is 1-to-1. So if I can do that for all of my even numbers, every single one of my even numbers, right? So I can prove that this bag is actually countable, and this bag is also countable in the same way, meaning I can get a 1-to-1 mapping between these two, right? And so I can say that the number of even numbers is the same as the number of all numbers in that sense, right? So there is a 1-to-1 mapping between these two. So what that means is that if the number of numbers is countable, so one of the things you'll encounter in discrete mathematics is the whole idea of countability, right? When something is countable, you can basically put your finger on each item and say, you can mark it off. That's gone, that's gone, that's gone, that's gone. So the number of numbers is countable, right? So the integers only, right, is countable. You can mark off, put your finger and count off, right? Same way the number of even numbers is also countable. You can count off, right? So they're all countable sets. So this is a set of numbers, they're all countable. So That's called countability. However, there are some numbers or some sets of numbers that are not even countable. And you can prove that this bag of numbers that are not even countable is actually a bigger bag than the bag of all numbers. Now, there's something that is really, really incredible that you need to figure out yourself. You can Google and find out. It's very interesting, and you can find out. And so the proof is also very, very interesting. We're not going to go into this. And it's a simple proof. You can understand it too, right? So the numbers, integers, are said to be, integers are sparse. The continuum is that line, x-axis and y-axis. They're called continuous lines, meaning that not only do they have the integers, but the line is completely filled in. It's not dots, it's solid. It's a solid line. It's a continuous line, meaning that 1, 2, and also all the points in between are there. That is called a continuum. So that is your x-axis and that is your y-axis, right? So it's those are called real numbers, okay? Real numbers, not integers, real numbers. Now, where was I going with continuum? Right, okay, all right. Now think about 1 and 2 numbers on this. The line is continuous, but 2 numbers are discrete, 1 and 2. Between the 2 numbers, you have a lot of fractional numbers, right? So you have 1 over 2, 1 over, or 1, 0, 1 over 2, 1 over 3, 1 over, whatever, right? So all the fractional numbers in there, right? All the fractional numbers between 2. Now you think, and I think too, well, I could possibly think, right? So if I had a line of just the lattices, 1, 2, 3, 4, and I go in and fill in the gaps with all the fractions, I can get a solid line. Yes? Okay, so that is the most mind-blowing idea, the thing that will happen when when you try and think deeply about it, is that even if I go in and fill in all the fractional numbers, there is still going to be more holes in the line than the dots that have been filled in. Now, think about how incredible, mind-blowing it is. What I'm saying is that numbers are actually sparse. This is called the continuum. The line is a continuum, right? Numbers are sparse in the continuum because they only occur at the lattice points, which is, distributed. However, rational numbers are basically ratios. Rational meaning ratio, right? Rational is ratio of one number to another. So 1 over 2 is a rational number. 3 over 4, rational number, okay? A rational number is characterized by an integer divided by another integer. Now, if I stick in the rational numbers into my bag of numbers, one could conceivably make the argument saying that this line, which not only contains integers, but also rational numbers between the integers, is now a solid line. Yes? Yes or no? Okay, all right. Now I'm going to leave this because it's not directly connected to CS2A. But if you will actually learn this if you do discrete mathematics. But I'm going to leave this in your hand. You don't have to do discrete mathematics. You just Google and go on the internet and find out, or just read a book and find out, or just sit down, right? Sit in a corner and think about it. You can find out. You can actually prove, right? Just like I did for even and odd and things like that, you can actually prove that you can create a one-to-one map between every single rational number and natural integers, right? Or natural numbers, meaning that you can put the set of all integers 0, 1, 2, 3 all the way up to infinity on a one-to-one map with the set of all possible rational numbers. Now, how is that even possible? Because we just saw that just between 2 integers, there's an infinite number of rational numbers, right? Between 1 and 2, there's an infinite number of rational numbers, right? Because it's also an infinite number of fractions between any two numbers. Now here we are making this incredibly preposterous claim that even though rational numbers are dense in the continuum, that's why, integers are sparse in the continuum, but rational numbers are dense in the continuum. What is meaning dense? What is the meaning of dense there? Dense means that if you give me any 2 rational numbers, doesn't matter, any 2 rational numbers, right? Meaning I give you 2 rational numbers that are so close to each other on the number line, right? I can give you another rational number that falls in between those 2, not equal to this, not equal to that, between the 2. Any 2, right? Any 2 rational numbers, I can give you another one that is in the middle. Now that is incredible, isn't it? And how do I do that? All I need to do is you give me the two rational numbers, I take the average and give you the middle one. That's also guaranteed to be a rational number. Yes, the average of two rational numbers is also a rational number, isn't it? Because the numerator and denominator take the lowest common denominator and add two fractions together, you get another fraction. So if I take the average of two rational numbers, you get another rational number between the two. So, but I cannot do the same thing for integers. If I give you two integers, 1 and 2, and ask me, give me an integer between 1 and 2, you say, no, I can't. There's no integers between 1 and 2, because the average of 1 and 2 is 1.5, and that's not an integer. Yes. However, if you give me a rational number, no matter how close those rational numbers are, I can give you another rational number between the two. So even if you take just two integers, 1 and 2, and ask me for a rational number, I could give you 1.5, which is 3/2, right? Which is between the two. Now you say, okay, well, you've narrowed the gap. I want to get a rational number between 1 and 3/2, between 1 and 1.5. I can take an average of those two and give you another rational number between those two too. So I can keep doing that infinitely, right? So even between two integers, I can get two rational numbers, I can get another rational number. So that means the rational numbers are very dense in the continuum, right? It's very dense, so dense in the continuum that between any two, you can get another one. Even then, okay, even then, you can prove mathematically that the number of rational numbers, right? Each rational number has a unique pair, unique partner in the set of natural numbers, which means that rational numbers are also countable, right? You can actually put your fingers on every single rational number in sequence, one after another, bam, 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 bam. So imagine, right? So we can come up with a technique where you can actually put your finger on rational numbers and go like this and go all the way up to the infinity of rational numbers. So which means that rational numbers are also countable. So which brings us to the question as to, well, now we have integers and rational numbers, throw in the rational numbers, which are really dense, and given any two rational numbers, I can always find another one in between. So if I keep doing that infinitely, I can get a solid line. So now my continuum, my line, my x-axis is not a broken series of dots. It's actually a solid line, because I have all the way from 0 to infinity, every single point is occupied, because I can keep on taking averages, right? So is that a valid, reasonable argument to make? Right? Integers and the fractions between them, rational numbers only, right? Is my solid line. Yes, is that a reasonable argument to make? Right, yeah, right? It's lovely when you actually say it is a reasonable argument to make, because in science, in math, in computer science, anywhere, right? So it's only after we look at a theory and say that is the most reasonable theory, right? There is nothing more reasonable than that. Only then will we start to appreciate why that theory is wrong. We, take a wrong theory and say, well, why did people come up with the wrong theory? Why did people stick around with, Newton's theory of gravitation, which we now know today to be wrong, right? It's wrong, right? But we stuck with it for how many years? Centuries. We stuck with it for centuries. And even today, people are still using it, for approximate solutions. But in order to understand why it is wrong, I don't know where I was going with that, but you have to understand why it actually works in the first place, right? And say that is the most sensible solution to gravity that we have. And once you understand why it is right, then you'll say, well, it doesn't work in this corner case, so there must be a better theory, and this is wrong because it doesn't explain that corner case, right? So that's why when you say, it's reasonable to say that even though, with rational numbers and integers, this line is continuous. It seems like the most reasonable thing to say. Now is where you can get, now you're totally prepared to get your mind blown, right? Because before knowing or believing that this is, obviously this is the most brain dead obvious thing, it's a solid line. Before you get that in your head, before you get that, you go and look at the proof to say why that is not true. That proof won't wow you as much. Okay, you won't get as much out of that proof. Saying, well, okay, it's just another math proof. But once you get it into your head, saying, well, rational numbers and integers, that's a solid line. Okay, there can be nothing other than that. And that means you're making a claim that's a solid line, and you believe very deeply in your head, and someone comes along and proves to you, I can show you a number. Okay, I can show you a number which is guaranteed to be a non-rational number, irrational number. Okay, irrational means it cannot be expressed as a fraction, right? No matter how big the numerator, no matter how big the denominator, you cannot get a fraction that represents that number. So that's called an irrational number, which means if I have an irrational number, it is not part of my bag of rational numbers. Yes. because it can be expressed as a fraction. Therefore, even though I have a one-to-one map of rational numbers to integers, I have one of those irrational numbers that doesn't fit in. Therefore, if I throw in irrational numbers into my bag of rational numbers, all of a sudden, this bag of irrational numbers is now bigger than my bag of integers. So, and the proof for that is actually very simple. It goes all the way back, right? Ancient civilizations in China, Egypt, Greece, right? They had already discovered irrational numbers. And in fact, the proof is so simple. The most common, one of the recent proofs is due to Pythagoras, right? So Pythagoras proved that the square root of 2, for example, there's so many numbers like that now. In fact, today we can prove that there are more irrational numbers, more irrational numbers than all of the rational numbers put together, right? So even though you have an infinite number of rational numbers between just 1 and 2, and equal, more and more infinities between every pair of numbers. So all of those rational numbers put together, which is the same as a number, one-to-one map to the integers, I can say that here's a bag whose cardinality means number of items in the set, right? Here's a bag of numbers which is even bigger than your bag of all rational numbers. Okay, and you can prove that. And in fact, the simplest proof is to say, here's one number. Just like, Jose said, 9 is the biggest number. And I said, no, 10 is the biggest number. I got a counter example, 10. So I say, if I come up with a scientific theory saying the rational numbers and integers complete my number line. There's no other numbers other than rational numbers and integers, right? Because give me any two numbers, I can take another rational numbers between the two. So I got all numbers covered. Now, if I say that, make that very bold claim, which is a scientific claim, someone could say, you're wrong, sir, because here is a number that cannot be a rational number. I can prove that this number is not a rational number. Okay, now how can you prove that a number is not a rational number? Now, in fact, here is an exercise for you. It is a very simple exercise, and you can look it up. Don't look it up, please. Okay, because the proof is, the proof that we have today is at least 2,000 years old. Okay, I'm pretty sure that similar kind of proofs existed in ancient civilizations also. But this proof that we have is due to Pythagoras, so proving that the square root of 2 is not a rational number. The square root of 2 can never ever be expressed as a fraction of one number over another. No matter how big those numbers are, you cannot get a rational representation. That is a proof, right? And so that is called the continuum, right? The continuum is basically the solid line, which includes all the rational numbers and also irrational numbers between the rational numbers. Meaning that if you zoom into the line all the way, right, you'll see that there are two irrational numbers, and there's no, two rational numbers, the rational numbers can go between them, but there is well, actually, I don't know how you can make that statement, but there are a huge number of irrational numbers, and the more mind-blowing thing here, and this, if you're interested, you can look it up. It is a proof that today, due to I think it's German or Austrian mathematician, right? He's called Cantor, George Cantor, I think that's his name, right? And so the proof that we have today comes from him that says not only are the number of irrational numbers more than the number of rational numbers, because we have this guy called Pythagoras who proved that there's one extra irrational number, which is more than all the rational numbers. It's one extra. No, that is, Cantor said, not just one. In fact, there are more irrational numbers than all of the rational numbers put together. Right, and you can prove that. You can prove that not only is the number line sparse, even though it's dense, it has holes. Not only does the number line have holes, even if after stuffing in all the rational numbers, the holes are more than all of the dots combined. Right, so you can actually prove that, and it's a very interesting proof, right? And you learn all that in discrete mathematics, okay? And it will eventually filter into computer science too. I don't know why we started talking about this in number theory, but certainly it's a fascinating field, number theory, and it has enormous implications in computer science. Okay, so that's why in mathematics there's two different fields. One is called the mathematics of real variables, which is all real calculus and everything continuous, and the other one is called the mathematics of discrete variables, where Diophantine equations or something like that, right? Where solutions to equations have got to be integers. You can't have fractions and rational numbers and irrational numbers, right? So discrete and continuous. There's two different realms of mathematics. They're both scientific realms, meaning you can make theories and conjectures and be disproven or proven. But they're two different things. Just like, you know, in computer science, things always branch off into, you know, some areas of specialization. So there's another thing for you to consider, right? If you are looking for juicy topics and subject areas to specialize in alongside computer science, right? So I don't want to say, all right, now here's some interesting projects in biology or something else, you know, learn that also. Yeah, okay, you know, all these empirical sciences, they'll help you to be a good machine learning and a data engineer, because for those fields, as I said before, they're not real pure sciences like math, right? Data engineering and machine learning, they're empirical sciences, like, you know, lab sciences, testing things and being bound by the external world and empirical phenomena. So, so you have these things. So yeah, so that's why I'm saying, you know, don't do, my recommendation is, if you want to major in computer science and you want something else also to work on that's interesting, but also related to computer science, and suitably different, you know, sufficiently different from computer science, so that you have two different areas of interest, so that if you get stuck in one, you can think about the other and come back and so on. Discrete mathematics and, you know, concrete mathematics, as, you know, Knuth calls it, I think, is a great area for you to get into. And you'll find it's actually very useful, because you can improve a lot of things in computer science using discrete mathematics, right? So you can, by counting techniques and so on. In fact, I posed a problem in, I think, was it Reddit? You have a tree. Well, we haven't even started talking about trees, but you know, traversing a tree is a very interesting problem, which we'll talk about, you know, in 2B. Right, assuming that a lot of you will go on to do my 2B and my 2C, which I really hope you will enroll in and consider doing. We'll talk about all these interesting things, right? And so many useful skills that you can pick up that will basically stand by your side as you're majoring in any subject, right? Area of specialization later on. So yeah, so I think that's about 8:33, our usual time when people will come in. Was this discussion about rationals and countability and irrational numbers useful at all in, or is just marginally interesting? Was it useful, do you think, or was it, do you think, yeah, okay, yeah, kind of, I think, yeah, kind of, yeah. It's not directly relevant, but I think it's useful in but, you know, setting the context for some of the things we'll discuss in computer science later. If you have any questions, please feel free to ask. And yeah, you know, the reason I was hesitating a little bit when I was saying that was because I thought I'd managed to figure out, you know, I thought I was confused a little bit about the proof of one-to-one mapping between the sets, because I thought, how do I account for that particular? I can think about that later in time. But certainly you should discuss this, right? You should discuss this. You can discuss the ideas about countability and rational, irrational in the forums. Say, hey, we talked about this in class, and here's a very interesting thing I found. Online, it doesn't have to be from our discussions or Reddit. It can just be, you know, something I found on Math Exchange, right? About countability. And here's some interesting juice for us to consider. All of those things you can discuss, okay, in the forums. Do you guys have any other questions? If you don't, we can basically start, we can pick up the code and start editing it. I think, who wants to code today, considering that all of you have had a chance to code. So anyone who wants to code will have the first priority, right? And then we'll go around and say, hey, can you code, okay? So, and remember, I think again, everybody's coded, you know how it goes, okay? It's all very easy and straightforward. We'll just be calling out the code. Yeah, Michael, thank you very much. And yeah, of course, you don't have a tablet, that's okay. We don't need a tablet. And are you on a Mac or a PC?
A PC.
A PC, okay, all right, PC, good. Yeah, PC is fine. You know how to start a command window on the Windows machine, right?
I think so.
Yeah, okay, we'll figure it out later. Where we can make it. Yeah, I think you just have to click the start button and then run command shell or something like that. But you don't have to do it now. We'll initially we'll develop on. We'll do it in online GDB as before, and when we get to it, we can if necessary move it to your PC and run it on your terminal. So whenever you're ready, pick up the code from Jaden. He posted it on Reddit, and then fork it, and then we can try to edit it. What we want to do today is create a movie, right? We're going to create a movie. And in fact, you know what? I'm going to excuse myself after about 10 or 15 minutes, hopefully no more than 10 or 15 minutes. You guys should just feel free to cut me off, okay? You should feel free to cut me off and say, okay, we want to start coding on our own. So professor, please get lost, okay? You should tell me, because today this is what I'm hoping. What we want to do is I'll basically set you up with 15 minutes of, you know, just refactoring the code a little bit to set you up for making that movie. And then you guys should basically maybe split into 2 or 3 teams. I would say maybe Michael and Tim and Changwen, who have already who have already made some progress in stickman drawing and things like that. They could play the role of the coordinators and say, well, this is what we're going to do in class. We want to produce a movie. And for this movie, we need these characters. We need a fallen man. We need you know, things like that. So you draw the fallen man and get back with you know, after you've completed the method, draw a fallen man, right? And so on. And you know, just dish it out and then pull it all back in and coordinate that into one single main, so that when you run the main method, you get a movie happening on screen. Okay, so I think that'll be really cool. So I hopefully it should take no more than 15 minutes to set you up now, because I think we have everything needed. Before you scroll, Michael, can I just take a really quick look at you know, from the top of the code, so that I can refresh my memory as to what we did. Okay, screen with constructor. Clear screen, we'll clear the screen. Okay, horizontal line, right? For now, let's comment out the diagonal line methods. Also, you know, we need to spell even though you're commenting it out, correct the spelling for diagonal. Okay, Gonal, right? Otherwise, you know, I don't know if you guys have watched the Harry Potter series, right? And they want to go to Diagon Alley, they just go diagonally somewhere. Okay, so do you guys remember that? I think it was in one of the early Harry Potter movies. They go to Diagon. He wants to go to Diagon Alley, where you can buy the wand, yeah, or something like that. Okay, Diagon Alley, diagonal line. Okay, and also there's Changwen's methods. Okay, even though it's, yeah, comment out the methods and also fix the spelling there too. Diagonal, Go, and then you can comment out the whole thing. Yeah. And the next one also, she's got two. Yeah, I fixed the spelling there. Okay, all right. So now here's what we're going to do. All right, so we gotta say, all right, say, and then we gotta paint, and we gotta draw a man. Okay, all right. So under draw a man, create another method called draw fallen man, which we're not going to do. You guys are going to do it. Okay, say draw a fallen man. Okay, draw a fallen man. Thank you. Yeah, thank you, Mike. Michael. Okay. Okay. Yeah. So same like that. Size T X, size T Y. Okay, and then put a comment above that saying this is the same as draw a man, except the man will be drawn horizontally as though he has fallen on the ground. Okay, and that's something you guys have to, you know, maybe draw it on a piece of paper and then find out the numbers for the corners and then import that into, right? So you're going to do that. Okay, now let's go to main. And I want to try something here. Okay. Yeah, thank you. All right, so let's do this. Okay. All right, so go to line 162, hit enter. And in fact, we can get rid of 158 to 161 because, you know, we just put it there to help us make sure that the whole thing was working, right? Putting the 4 stars in the 4 corners. Yeah, great, thank you. Right. So now let's do a for int I equals 0, size t I equals size a loop for 100 frames. Okay, 100 frames. Yeah. Okay. Now, and let's make this a little cleaner. Int main, after int main, say const size t number num underscore frames equals 100. size t num all uppercase num underscore frames num underscore frames all uppercase num frames num underscore frames number and get rid of the num under before num underscore frames equals 100 a semicolon and enter. All right, now you can change the 100 into on line 164 to num frames, right? And then I equalize the spaces around the operators because I equals has on this side and not on that side and so on. Yeah, okay, cool. All right, okay, now what we want to do is I'll also put a blank line after the closing parentheses of the for, so we can now start filling in the for loop. After the for loop, put a blank line, right? Okay, now we'll put a comment on top of the for loop, enter, and say we will draw a number of frames starting at the same top left location and sleep 500 milliseconds. Let's say we sleep 500 microseconds, right? Sleep a small amount of time, right? Sleep a small amount of time. We don't know if microsleep is going to work, okay? So sleep a small amount of time. Between the redraws, so it looks like a flip book animation. Okay, so that's what we're going to do. And in here, what we'll do is inside the for loop, what we'll do is the first thing we want to do is clear console, okay? Because clear console is the way we found that we can yank the cursor back to a fixed place, right? So clear console, which is a global function, does not need a screen. Yeah, okay. Now, after you've cleared the console, what we want to do is scr.drawMan. Okay, scr.drawMan. Now here, what we want to do is let's say 5 plus I, right? 5 plus I. So meaning that 5 plus I, comma 3. Yeah. On the next line, you want to say scr.say hello or something. You know, you can say whatever you want, right? Yeah. What's up, right? Question mark. Yeah. No uppercase for you, right? Because right, cool. All right. So what's up? Do we need coordinates? Yeah, we'll say coordinates. So we'll put coordinates there. Let's say 20 plus I, comma 7 or something like that. Okay, now you want to do scr.paint. You want to paint that on screen, and after that you want to sleep for sleep 1. Yeah, sleep 1 for now, and then we'll experiment with microsleep. Okay, after that, and after you sleep, you want to clear the screen. So scr.clear. Yeah. Semicolon. Let's do one cosmetic change, if you don't mind, Michael. Because it's SCR, it's a method of the screen class. We don't have to qualify it with a clear underscore screen. We'll just call it clear. scr.clear means clear the screen, right? So just, yeah. And then we need to change the definition and also the declaration. Definition and the declaration. And cosmetically, I think it'll look better. Yeah, and then also there. There you go. Clear, great. Oh, I see. Yeah, okay. And then in your main, you can get rid of all of that in main. Yeah, you can get rid of all of that. You just delete it. Don't comment it out, because if you comment it out, the code starts looking bigger and bigger, and the students may get intimidated. You can also delete the bottom, that part, which is all history, right? Ancient history. Okay, now I think, is that it? Clear console, draw the man, say something, and then paint sleep 1, and then clear. Clear the screen. Yeah, here's what we can do. Yeah, I think that's fine. Doesn't matter. I was thinking whether screen.clear should go at the end or at the top. It doesn't really matter. Okay, so we're good. I think that if we run this, we should see the stick man, move 1 second at a time, move to the right. We'll see if that works. Okay. Screen is 100. Make the screen 120, right? 120. Because
should we decrease the number of frames? I think frames is a lot. It's going to be 100 seconds. I mean, we can kill it.
Oh yeah. Make it like 30 or something. Because when we go to microseconds, we can turn that to more frames. Yeah. So I think that should be sufficient for now if you run it. Okay, let's fix it. Oh, draw fallen man is not in the declaration, so you need to go to triple click on the line. Triple click and then copy, and then you can put it up there. No, you got to get rid of the screen double colon.
Oh.
Yeah, and also move draw fallen man under draw man, because once you have draw man, then it makes sense to also do the draw fallen man. Excellent. Okay, all right. Now if you run it, I think increase the size. Okay, all right. Well, yeah, certainly he's moving, and we got to something funky. What's going on there? Okay, that's for all right. Do you want me to debug it, or you guys want to debug it? It's going to be easy to debug. Okay, it's going to be easy to debug, and I can debug it obviously. At this vertical line, there's a bug in the vertical line method. Okay, now I am confident. I'm like 99.9999% confident. Well, not in continuous space, in discrete space, let's say. All right, right. I'm very confident that you guys can fix this issue. But before I hand it over to you and say fix it, let's try microsleep to see if microsleep works. Okay, so go back to your code. So instead of sleep, say you sleep, and then instead of 1, say what is 500? Hey Google, what is 1,000,000 divided by 500?
1,000,000 divided by 500 is 2,000.
Okay, right. So what we need to do is no, not 500. It's got to be 50,000, right? It's got to be 50,000 because we want to have 20 frames per second. Hey Google, what is 1,000,000 divided by 50,000? 1,000 divided by 50. That'll be 100 divided by 5. It's a 20. Okay. It didn't answer. Hey Google, what is 1,000,000 divided by 50,000? That's 20.
1,000,000 divided by 50,000 is 20.
Okay. All right. So you will get 20 frames per second, right? This way. So let's run it and see if the animation is faster. See, that is a total bummer. Okay. Now this effect will not happen when you run it in your terminal. Okay. In your Windows prompt. So you want to try that in your Windows prompt? I can show you how to do this. Right, copy the whole thing and go to your VS Code. Copy this whole thing. Command A, copy it. Go to your VS Code. And share your VS Code window. And then we'll compile it. And then we need to find the .exe file. Right. So can you build it here in VS Code? I think a build should be somewhere. Run build. Right. Oh, you don't have usleep. What a bummer. You don't have microsleep in Microsoft Windows. We did find out, right? We Googled and tried to find out. How do we do?
I think I just include the uni std,
Oh,
right?
Try that. I thought it was already included.
Actually, yeah, it's already included. Never mind.
Yeah. No, it was. This is. I'm remembering back over a decade, right? 15 years ago, I tried to do something like this, and found that, microsleep was not available in Microsoft Windows, and I thought, what a pain. And it's still not available. No, it is possible, by the way, right? If you go to Stack Overflow and say, how do I do microsleep in under Windows? I'm sure you will find this is how you do it, but it's not like one function call, like do microsleep, right? You got to do like 4 or 5 lines of C code to do that. I'm going to try and think about how we can do microsleep in Windows. Do you have access to a Unix terminal of any kind? Right? Can you log into a Unix terminal? Do you have a Mac? Do you have or do you have a cloud account where you can log into a Linux terminal? Do you have access to a Linux PC at all? No?
No.
How about just this part where we do it with a microsleep? Someone with a Mac, we'll try it and then we'll come back to you. Okay. Well, actually, this is it, right? This is it. This is the end of my being involved in this project. Because after this, I'm going to hand over to you guys, and you guys are going to be doing the rest of it with the animation. So how about at this point, we get Michael to share the URL, okay, for in online GDB, and someone who has a Mac. Who has a Mac? Can someone who has a Mac just tell me? Yeah, okay. All right. We'll go with Kate, okay, because Jaden, you just volunteered last class, right? Okay, Kate, so if you can pick up the code and then I'll show you how to do this in Mac, okay? So pick up the code from Michael. Michael, share the URL in chat or something. Okay, and Kate, you can pick it up and open up a Mac terminal. In fact, you can do it in terminal. Okay, I'll show you how to do it in the terminal. It'll be really fun. It'll be an extra skill. Do you guys want to do it? So, Kate, if you're okay with it, I can show you how to do it. Because in a past class, I think Ali, I had a student called Ali. Very good at everything and coding and everything, but she was somehow uncomfortable with the idea of using the command line. Right, command line, and she said, using Xcode is okay, but going into terminal not so okay. It's a silly block actually, because if she sat down and thought about it, she'll find it's actually not a big deal. So I think it is very useful to get familiar with the command line interface of any operating system, whether it's Unix or DOS or Windows or Mac, because that gives you a huge amount of power. Great, thank you so much. You've got it? Okay. Now, can you, inside of this terminal, can you hit command plus a couple of times? Command plus. That's great. Yeah. Okay. Now, hit the green. No, just hit the green circle and make it span your whole screen. Okay. Now, have you got the code copied? You hit Command A and copied the whole thing in your buffer. Great. Is that the whole code? That's not the whole code. Is that the whole code? It is the whole code, is it? I can hear you, Kate. Is your microphone switched off or something? Yeah, copy the whole thing. Command A and then Command C. Command A, Command C. All right. Now go to your. Now here, hit Enter a couple of times. Just hit Enter a couple of times. Why can't I see? Oh, yeah. There you go. There. That's much better. That's much better. Now, yeah. So do this, okay? Before you paste it. CD, that's change directory, CD space /TMP, right? Okay, TPPP, temporary, TMP. Now, there is a special directory, right, folder on a Mac, Unix machines, and even in a Windows machine, even though you can't see it, it's called the temporary folder. The temporary folder is available to all users on the computer, right? On Kate's Mac, for example, Kate's got one login, right? Maybe her sister or brother or parents or whoever, right? When she goes home, they also have logins on the same Mac, right? So many people can log into the same Mac, yes or no? Right? So each person gets their own home directory on their Mac, right? Their own place where they can put these things. So, and they can't go willy-nilly to any place on the Mac and say, well, I want to create a file in Kate's folder, right? I have my own folder. But I say, I want to create a file in Kate's folder. I want to edit Kate's folder. No, the operating system will make sure you can't do that, right? It's got protection. So you can only play around in your own playground. You can go to someone else's playground. However, in the operating system, it gives you a special public playground. It is called /temp, right? Anyone can go into /temp, which is your public playground, and create anything you want out there delete the stuff that you have created, which belongs to you, but you cannot create, you cannot delete and edit someone else's stuff, which can also live in the same playground. So /temp is a public area in the computer where you can go and create stuff and you can play with it and delete it. And also other people can do that, but you can play with other people's stuff in the same area. So /temp, we'll come there, we'll create our project there because it's a one file project, right? So we'll just create it there and we can leave it there. You don't have to delete it. It'll just go. The next time the machine is rebooted, that, you know, so a lot of people, what I do a lot of times is when I want to create simple programs to test something out, I just create it in /temp because I know I can leave it there. It'll go the next time. It'll be deleted. I don't have to worry about cluttering up my home directory, because if I do it in my home directory, at the end of the month, I'll find there's a whole bunch of experimental files there, right? Which I don't even want to keep. So this is a good practice to pick up, is whenever you want to test something out really quickly, do it in /temp, okay? Because it'll, right. So enter there. All right, now if you do an ls space -l, it'll tell you all the files that are already there, right? In this public playground, you'll see all the files that are already there, right? So hit enter, right? So these are all the files that other people have created, right? So Kate, you know, created a file called lose, and then the operating system, which was run by Kate, and created all those other files. See that it's owned by Kate Larrick, right? So Kate Larrick owns all those files. And obviously, you know, she's the only one who's been using the computer, because if, for example, you know, she had relatives, maybe a brother or sister, right? And they also created files on here, not in this directory. They could be, you know, playing around in their own directories, but the operating system will create files on their behalf here. Right, so you'll see their names also, right? So, all right. So here we're going to create a file called movie.cpp, okay? And we'll just create it in a very primitive way. You're not going to do this ever, I think, right? This is a very primitive way, and you only do this when you are sure that the file actually does not need to be edited by hand. And the way you do it is a cat space greater than sign, okay? Greater than sign. Movie.cpp. Okay, enter. Now you can paste your code, right? Command V. All right. Now hit enter. No, not hit enter. Hit Control D. Control D. Control D. No, you did Control D. Okay, good. All right. Now if you do an ls-l, which is up arrow 2 times, two up arrows, you'll get the same command, right? All right. So if you hit enter, you'll see movie.cpp there somewhere. There you go, right? This is at the end. You see that file, movie.cpp? That's the file that we just created. In fact, that file has everything that Kate basically dumped into that file, right? So if you want to see what's in the file, you can just say cat space movie.cpp. Don't cat space movie.cpp. Hit enter. You'll see all the contents, right? Why is that? Why is the thing divided into two? Why is your screen divided into two? That's really funky. Yeah. Okay. Drag it all the way to the top. We don't need it. Okay. Right, so that's a file that we just created. Yes, it's right there. Now what we can do is do exactly what Xcode is going to do behind the curtain, right? So when we create a program in Xcode and say Xcode, go ahead and compile it and create a binary and executable file that I can run. This is what Xcode is going to do. Except we're not doing it through Xcode and the fancy graphical UI. We're going to do it by hand, and this is what Xcode will do. G++ space -O. Space movie, MOVIE space, and then MOV, and tab. Hit the tab key. It'll autocomplete for you. All right, right now that is the G++ command, which will take the movie CPP file, which is in C++, and it will convert it into a binary file, movie, right? And that movie file is now cannot be understood by us, but the CPU can understand it and run it. So hit enter. I see. Okay. Now we have to edit it. All right. We'll put a flag there. Okay. So up arrow. One more time. No, not caret. Up arrow. Yeah, right. Now backspace, not backspace, back arrow until you get to the place before the. Oh, you can actually put it at the end too. That's fine. You can put it at the end. I think dash std equals. I think this is what it is. Okay. C++ 0x. I don't know. This is 0x. Hit enter. Wow. Okay. All right. You know what? I just pulled it out of memory and it worked. I haven't used this for like over a couple of years now. So that says compile this program, but don't use some ancient version of C++. Use a 2000 version or a recent version of C++, which actually understands that when I have a template class like this vector, the two angle brackets don't need to be, spaced out. And in ancient days, old C++ compilers used to complain exactly like what Kate's got here, because it says, hey, you got two greater than signs in your code. I don't know if you actually mean vector template completion, or it is that, C in greater than variable, right? That operator. So it doesn't know whether it's, so it can't disambiguate, and that's why it's complaining. But later on, C++ designers felt, why are we making that silly warning message appear when we can actually programmatically find out whether it's a template thing or not. We can handle it on. All right, so now it's compiled. Now if you hit enter, oh, it already compiled it, right? No, the previous, two up arrows. Get the previous one. 2 up arrows. Yeah, hit enter. No, down arrow one more time. Yeah, enter. It's compiled. Okay, now if you do an ls-l, you'll find a file called movie, which you can run. Yeah, enter. No, just, yeah, okay, that's fine. You can, you can just say movie and it'll tell you, oh yeah, enter. Right, so that's your file. It's 96,000 bytes long, and you can run that file. And you can run that file by just saying /movie, okay, /movie. Enter. Oh, you need to, okay, no, command minus. Hit command minus. Now you can increase the size of the, increase the size of the, now you run it again. Control L and run it. Yeah, Control L and then run it. Up arrow until you get, up arrow. Yeah. Oh, did you move it up and down, or did it automatically move up and down itself? Did you move it? Did you scroll up and down, Kate?
I don't think so.
Why is it moving up and down? It shouldn't move up and down like this. Hit Control L. No, Control L. Okay. Now, why? How did it scroll down? We hit Control L. It should be at the very top. Oh, all right. Don't do anything more now. Okay, good. Now just type /movie and hit enter. Don't do anything after that. Okay, all right. Okay, all right. So it is working. Why? It's less than 1 second, right? It's less than 1 second. Did we use microsleep or sleep? Do the movies.cpp?
Yeah, it's
movies.cpp.
microsleep.
We did microsleep?
Yeah, you sleep,
okay.
yeah.
Okay, so it actually works. We're getting 20 frames per second, right? We're getting 20 frames per second, and the man is actually moving. So it actually does look like a flip book movie, right? Now, okay, so are you guys comfortable with me leaving this in your hands? You got to do 2 things, okay? Number 1, you all together, okay, have to figure out why the vertical line is not being drawn, okay? So there's some kind of bug there. You got to figure it out. I can fix it, but I don't want to fix it, okay? I want you guys to fix it, and I want you guys to fix it before the end of class. What time is it now? 9:04. We got a lot of time, okay? So, target, okay? This is your target. That bug, the vertical line bug, should be fixed before 9:20. You got 20 minutes, okay? 15 minutes, right? 9:05 to 9:20. 15 minutes together, all of you, have a heated discussion, right? And say, hey, running out of time. Someone give me some ideas, and so on and so forth. Kate, can you volunteer to drive? Oh, you need to get into how to edit this file, right? Do you know how to use an editor called VI? Do you know how to? I see Xcode. Let's try this, okay? Let's try this. You can close the browser. You don't need the browser anymore, right? Close the browser, right? Type this, okay? Type Xcode space / movie.cpp. Enter. We'll see if. Okay, just open up, run Xcode. Yeah, create, open a project or file. Actually, no, kill this and open a project or file. Yeah, kill this and open, Xcode, open a project or file. The last option on the left. There, that one. Yeah. Right now here, what you want to do is how do you go to /tmp? Where do you say drop down for pet? Drop down. You have the drop down for pet, right? Yeah. Go. You get /temp there. Okay. Here's what we'll do. Copy the file. Go to your terminal, please. You just 2 seconds, okay? 2 minutes. Copy that file. So we're going to say cp space movie.cpp space tilde. That's a shift backward. Yeah, tilde. Is that a tilde? I can see, right? Tilde slash capital DESK desk space tab, just tab. No, not yeah, tab. Right. Just copy that. Okay, yeah, enter. Now, if you look in your desktop, you'll find that file, right? If you look in your desktop, don't open your desktop like, okay. You'll find that file right there, movie.cpp. Okay, all right. Now in your Xcode, oh, that is Xcode. It is Xcode. Cool. You can actually edit it. All right, great. All right. So there you go. Now, this is where you got to fix the file. Okay. Now all of you together, you're going to fix that vertical man bug here. Okay. The vertical line bug in here. Okay, you can edit this, right? This is editable, just like Xcode. Edit it, save it with Command S, and then you can compile it here though. To compile it, what you need to do is go back to your terminal. Go back to your terminal, right? Now cd space tilde /desktop. Yeah, tab will complete it for you, right? Yeah. Enter. Now you can do an ls space -l, ls space -l. Don't hit enter because it'll show me everything on your desktop. Space movie and then tab. It'll say movie.cpp. Yes, say yes. Yeah. Okay. Right. Now hit enter. This file is right here in your desktop. Now you can compile it too. Up arrow until you get the G++ line. Up arrow. I think one more. There. Enter. Okay, now we took the file from /temp, which is not accessible via Xcode apparently, and put it on Kate's desktop. Now Kate can edit the file using Xcode, and you guys all together can fix the vertical man bug. Okay, and you should also ask Kate. Hey, Kate, I think the bug is elsewhere in the code. Can you scroll down a little bit so I can read it? Scroll up and all those things. Kate can help you out. But the goal here is all of you try and figure out the bug. And after you edit it, to compile and run it, you go to the terminal and up arrow, get to the G++ line, compile, right? And then it's basically 2 steps. Instead of doing everything in Xcode, we're doing the editing in Xcode and compiling and running on the terminal. Are you guys comfortable with that so far? Right, we just split up the 2 steps. Usually you do everything in Xcode. We said we're only going to do the editing of the program in Xcode, editing and saving, but compiling and running, we're going to do it on the terminal. We just split it. Otherwise, Xcode will do the whole thing for you. Right, but we just found it's a bit of a pain because clearing the screen doesn't work so well in Xcode. That's why we're doing it in terminal. Are you guys comfortable with that? Are you okay with that decision? Yes or no? Okay, and obviously Kate is nodding her head, so I think that even if I'm gone, if you have any questions or get stuck, I think she can help. If not, you can always call me. Okay. No, don't worry, Kate. Okay. If you're not able to, if you don't know the answer to a question someone asks, you can say, hey, well, let's ask Anand. Okay. And just call me. I'll come over and say, well, I'll take a look. So there is no need to be concerned or underconfident or in any way. Everybody should just feel 100% at home, right? Because this is our home. This Zoom class is basically our home, and we're all related to each other. We're just going to be asking, hey, can you do this, right? You ask your brother or sister, can you get me the jar of jam or something like that, right? So like that, you're going to ask each other for help, and you're going to be helping each other and fix that vertical man bug. Number 2, 9:15. Hey, what time is it now? All right, let's say 9:30. Okay, so when you're done by 9:30, you're going to start working on Fallen Man, okay, and Chongwan and Kate and all of you guys get together and make that movie where you have 2 men starting out from this side and that side. This man is going to have X plus I, right? This man is going to have X minus I, so they're moving towards each other. At some point, you got to find out when they meet, okay? So you got to figure out exactly when they meet, and when they meet, you're not going to draw another offset man, you're going to say boink or something like that up there. Say boink, okay? And then you're going to turn one of them into the next frame is going to be fallen man, okay? And that's the end of the movie. And you can say end, all right? You can say end at the top of the movie, right? So that's your only movie. And when you've got that going, I can also show you how to make a sound when the two people, hit each other. You can say, bell, bing, or something like that. So you'll actually have an audio-visual movie created in a flipbook movie in class in week 8. I am actually looking forward to seeing that movie. Okay, so we'll actually have a movie. Don't worry. Okay, there is absolutely no reason to be concerned in any way. Okay, and if you're feeling antsy or saying, oh, I don't know if I can do that, fantastic. Okay, that is a feeling to relish. Okay, think about it. Later on, you're going to get projects and you will not have that feeling. Okay, many times after you develop a certain level of expertise, when someone says this needs to get done, most of the time you tend to figure out, okay, these are the steps that need to get done. All I need to figure out is find a time to sit down and assemble people and get this done. Okay, you will lose that feeling. You will lose that feeling of oh my gosh, how the hell am I going to do it? Right, that panicky feeling, you will lose it. You'll stop feeling it after a while. So you have to remember this very, very clearly and say, oh, wow, this is how I feel at the beginning of a project, because now I can say, right, that's how I felt. After I finished it, this is how I felt. So you can have a complete map in your head as to how you started with the total panic and you got a finished product, no panic at all. So you have to have that trajectory in your head, right? And I think it'll be a very useful trajectory, because later on, what I found is that whenever you hire newbie programmers, at some point you're going to hire newbie programmers, right? The biggest challenge that they find is panic. Right? Because newbie programmers, they've built a project at home, in their garage and things like that, small projects. When they come to a company and they have to start working on a big project, large project, right? And you give them this task saying this needs to get done, and they've never done something that big before, right? And so the first thing they experience is panic and say, wow, am I going to get fired because I can't make head or tail of it, right? And actually the problem is, it's a self-fulfilling prophecy. If you feel that, oh my gosh, am I going to get fired because of this? Chances are they get fired, right? The people who don't get fired are the ones who say, oh my gosh, I don't know how to do it, but I can do it. Okay, they won't get fired, because even though they both feel the same amount of panic, one of them says, okay, well, it's a panic, but I know I've encountered this a million times in the past. They won't get fired. Okay, they both exactly feel the same thing. But one person will succeed and the other one won't. That's why I'm saying that this is actually super important. If you feel panic, feel the panic, okay? And also feel the panic and watch it. Don't feel the panic and give up. Feel the panic and watch it move, right? And feel the panic get less and less. As you move through the code and get more and more help from other people, you'll feel the panic go and finally disappear, okay? When you feel it vanish, and feel that 10 or 15 times in your life over the next few months, okay? Then you're totally set up to be a programmer. And because no matter what task someone throws at you, you'll know it's just a matter of time. It's a matter of time and resources, right? Even if you don't know the answer to something, you'll know. I can get one of my colleagues, or ask on Google, right? Stack Overflow. I can solve these little problems, put them all together, I get the whole solution. So I don't have to panic. It's just a lot of work, okay? And it's also interesting work. So that's the mindset to get into in order to be a successful programmer. Okay, are you guys okay with this so far? Can I leave this in your hands? Right? I want to be listening to and hearing a lot of your conversation. So the things to do: number one, fix the vertical thing bug. Number two is do the animation. Let's get all of that done, because next class, Tuesday, I want to start talking about searching and and stuff like that. So we won't do this anymore. So hopefully this is the last class. But not, you should also be working on it over the weekend and, after today and so on and so forth, get extra, and not extra credit, participation points and so on, and also produce an interesting movie, right? So you should be able to do that. But this is the last class we'll formally talk about that. So you should yank me back. Whenever you have a doubt or something you need input on from me, yank me back. Otherwise, I'm going to leave it in Kate's hands. Okay, she's going to be driving the bus, and you're all on task. You're all being tasked with creating a movie by the end of today's class. You got almost a whole hour. I want to see that movie by 9:50. Okay. So thank you all so much for treating me to a fantastic film at the end of week 8. So I'm going to leave this with you now. Are you guys okay? Do you have any other questions for me? No? Okay. All right. I'm so psyched to hear you guys say that. And remember, I'm just a holler away. I'm just going to be here and call me. But I'd like to see that happen. Okay, today. And I'll come back at 9:45 or something, okay, before you go, at 9:45, and all of you should help, okay? Anthony, Kiki, Chongwan, Jose, Michael, and Jaden, okay? All of you, and Tim, right? Help Kate, and let's fix it out, figure it out, and take a copy of the code so that if you think there's a bug somewhere, and Kate is up here working on some other bug with someone else, you don't have to wait for that bug to be fixed and ask Kate to scroll down. You can look at your own copy of the code at the place where you think the bug is, okay? So you can do all that. So Kate, share the code somehow on, you don't have to share the code, it's on the online GDB, right? Just share the URL, the fork URL, which we've changed now in online GDB. And or you can copy this and put it in online GDB and copy it, and people can take the code and work on that. Is that okay? Can I turn the laptop around and you guys are good to go? Thank you. Thank you. All right. I'm looking forward to seeing some action here. Thanks. Bye.
Look at the code.
Right, do you guys know where the bug is?
I'm not really sure because it was like before this version, it was still having that problem where the two sides of the head and the body seem to disappear halfway through the film.
Yeah, I'm trying to find it, but I don't know where to look.
Do you think we're moving each pixel too far each time it goes in transition?
Yeah, I mean, it seems to stop working at a, certain position. So I'm
Doesn't Draw Man have a limit to the max and height?
let's see. Yeah,
Like,
it has
Greater than 13 or something.
the return false one.
Mm-hmm.
I don't know. I tried adding like just a random number, like 50 instead of 10, and it's still getting that same bug.
sorry, can you run the animation one more time? Seems like it happens like 3 or 4 frames into the film.
It's like let's see. Roughly 26 on the X. Yeah, I mean, the only thing I've tried is adding the adding like a random value to the X for the if statement, the if return false. That doesn't seem to be working. Maybe I can try a lower number, see if that works. But, yeah, I'm trying to just see why it looks like I think what's happening is just, it's returning false for either draw man or draw vertical line. But I don't know what values to play with to increase the X.
Well, sorry. So how much? So how much would? Because when it says it returns false, it's happening when x is greater than or equal to pixels dot size. What? How much does pixel dot size usually carry?
Yeah, I'm not sure. I think we set the pixels early on. I don't quite get how the pixels are size or the set pixels are sized because let's see, looking at set pixel, the size is, if the size is 0, if y is greater than pixel dot size, return false. And if x is greater than equal to pixels square bracket y, return false. And then it creates a star. Uh, Do you guys know why screen size is based off y? So it says underscore pixel resize y, and then for size ti equals 0, I is less than y, pixels square bracket I is resized to x. Where's that? Oh, I guess, no, that's, okay. Okay, do you guys know where we should be looking?
Yeah, that's actually what I was gonna ask. Where do you think? Where do you can hypothesize where the problem is coming from?
Uh, Probably draw vertical line or draw man.
Yeah, because it's the heads that disappear first. The heads and the body.
I mean,
Wait,
somewhere in vertical line.
could it
Uh,
be? Maybe it's. Do you think it has to do with those numbers y plus 13 and x plus 10?
Mm-hmm. I just suspect that because it doesn't move up and down at all, so it's not affecting those values. But because it's moving to the right, if something's wrong there with like how far it's offset, it might think it's out of bounds when it's not.
Right, because it's set to y plus 13 is greater than or equal to, that's when it returns false. So do we have to like downplay what like draw horizontal line y plus 1 x plus 7 to lower numbers or?
Mm,
Okay, I think I found it. But, all right, I think I found it. Okay, but you guys have to help me understand why. So, okay, if you go to draw vertical line, the function. So it looks like, so for the for loop, if you go to the for loop and the x is less than underscore pixel dot y, wait, is it y? Draw vertical line y. Oh, why do I have x? Oh, did I? Huh. I have that value as x instead of y.
Weird.
Anyway.
That
Oh,
wait, did
wait,
that
am I,
value?
sorry, I'm looking at vertical, sorry, I was looking at horizontal line, that was my bad. Sorry, so yeah, vertical line y is less than underscore pixel. I changed the pixels to y inside the square bracket instead of x, yeah, and then try that. But I'm having trouble understanding, well, let's see if it works first.
So when I save it in Xcode, does it save directly like?
I don't know, I think you
thing
have
with-
to,
You have to like redo everything, you know, like,
yeah, I think you do.
I don't know if I could even find it. Do you remember? doing that?
Wait, just up arrow. I think you might be able to. Well, try running the movie first and seeing what happens.
Yeah.
Okay,
it's-
so
it's-
yeah, I think you need to recompile it or
Okay.
whatever, reconvert it to the binary file. I think we can just use up arrow to see what we can do. Um, okay, see, we're in desktop.
Yeah.
So, I think go down to the G++ again. Yeah, that one. I think, yeah, so that will change the file. I think now is updated. And then try running the movie. Nope. Let's see, are we doing it correctly? We're in desktop, the file's on desktop. Oh, can you check your file again? Maybe, I don't know if it changed back.
Check which one?
Oh, the movie file in Xcode. Okay, still the same. So how do we do this? Oh, do we
Try
save
out
it?
one more thing, maybe in the code.
Oh, yeah. You had an idea.
If you go to line, let me see, 79,
79.
and add a square bracket after pixels before the dots, and put Y. Let me see. Yeah, and let's see. If
It should be Y1 or Y2. We don't,
I think it's Y.
we haven't declared
Y1.
Y.
Yeah, we can put a Y1.
I went. Okay. Okay.
Let's see. Okay, let's see. Oh, are not identical, copied. Oh, what's that mean? Let's see. So did we save the movie file? I think we did, right?
Yeah.
And this movie file is on the desktop.
I think so. Uh, yeah.
Okay, let's try, let's see. Let's just do some up arrows to see which commands we can to do again. I think just keep going. I think. I think it should be the command with the G++, right? It'll take the movie and convert it to a binary file. Should we call it something else? Maybe let's call it something else so that we know what it is. So hit the up arrow to go to the G++ command. Okay, and then go all the way back to movie, the movie,
Yeah.
and let's just say movie 2 or something, or movie 1, so that we know that what it is. Okay, and then hit enter. Okay, so let's see, did it create a movie 2 file on the desktop?
No.
Oh,
Okay.
oh, there it is, movie 2. Okay, yeah, try running movie 2. That'll work. There we go. Yay. All right, cool. Okay, but I honestly I don't know
Yeah.
why changing the pixel value to Y. Anyone know? Let's see. So draw vertical line. So originally, what do we have? Originally, we have was it X, right? So
Yeah,
we
it
had
was an X inside pixels.
Yeah.
So
I don't put anything here.
I think if you put it, change the Y back to X, it will still work.
okay, let's try it.
You can try. That's why.
This.
Yeah. Yes. And we can try.
All right. Should we rename it again?
Yeah, we can call it like movie 1 or movie 3. Okay, on my end it's not.
Okay.
I think you can just hit enter. I don't think you need to go all the way back to the end.
Ooh.
It's not working.
Yeah. So this has to be Y.
Yeah, so I'm like confused on so you're saying, so I guess the for loop is that Y is less than pixel, and it's going to be the Y position of the pixel. What's the difference between the Y and the X position? The Y.
Maybe
Yeah.
it had something. Maybe it had something to do with. Okay, no, never mind. I don't think it was going to be like that, but maybe it had something to do with taking like a value if X is greater than or equal to, while the y over here was taking y is less than pixels y while also having x inside of it. So maybe that was messing up, but it's a return false, return true statement. I'm not sure.
Pixels is a two-dimensional vector, right? I think so. I haven't worked much with two-dimensional vectors, so I'm a little confused on the pixels. So it's two-dimensional vector. Yeah, I'm just not sure for the explicitly the pixels when you're calling the two-dimension. So because it's a two-dimensional vector, I'm not sure why why there's always only one square bracket instead of two. So you're only calling, so if you're only using one square bracket, are you only calling the, the first row of elements on that vector? Does that make sense what I'm trying to ask? I don't know. Okay, but anyways, yeah, we can move on and draw the other stickmans. At least the bug's fixed for now. What were we supposed to draw? Was it just the guy falling down or the boinking?
Can we
Yeah.
try maybe delete the whole thing before and see if it works. Go back to the vertical. How if we delete y is less than the whole thing, if we delete it, would it still work? And even the n percent, the two n%.
Like this.
From the semicolon to the n%. After this. Yeah.
To here.
Yeah. Just try. I'm not sure.
Okay, let me copy it real quick. Okay. Resave it.
Oh, nice.
Okay.
Oh, that one is already redundant.
It's not working on my end. Let's see. Let's see. So you just removed that. Yeah, y equals that. Yeah. Okay. Trying to move y1. Yeah, I'm not sure why it's not working on my end. Let me try that. Y less than, oh, wait, maybe maybe it might have syntax error. Whoops. Okay, let's try that. No, still not working. Can I see your draw vertical line again? Thank you. Let's see. Oh, I see. Okay. Oh, great. Awesome. It's working. Okay, cool. Why is that, Shangwing?
If you put, if you I think that the previous condition, you put something that is the limit is higher than the y2. I think it's the width of the screen, which is 99, but y2 is always less than 20, 25. So that limit will never reached. So it doesn't matter if you have that additional condition. Does it make sense?
I think so. I think, yeah, I think the main issue is that the underscore pixels was limiting the,
So this
yeah, it was
one,
limiting the for.
this size of pixel y, I think it should be 99, which is the width, not the height. I mean the height. It's only 25, not 99. So
Oh, okay,
condition will never be met. That's my guess.
okay. I think, okay. Y1, okay.
But probably we should put some other conditions to it, because if we want to draw some figure like falling down, we probably need some condition to make sure it's not it's in the screen, or but we can leave it, maybe leave it for now.
Did he want a fallen man or another man like going in the opposite direction?
Can we try the falling man?
Not sure exactly how to do it, but I'm sure in theory, if we take the existing lines that we have for our standing man and just swap the X's and Y's, it should create a fallen version.
Sounds good to me.
So are we swapping like all of these?
Wait, so would we have to resize each of those y+1 and x+7? Or
Oh, okay. All right.
so how much should we resize them?
I have a feeling it's not going to be so simple as this, but
To be safe. Do we want the same size as here, like also 5 plus I and 3?
Gonna
Well,
print him right at this. Oh no, never mind.
they'd be like on top of each other, right? If it was in the same spot.
Yeah.
Okay, let's play this.
Did we get rid of the hello there?
What was that?
Yeah, she got rid of the WhatsApp.
Oh, okay.
I was just gonna put the fallen man like next to it instead, but it is not there. So let's try it without a boot.
All right. Did we get a chance to run it yet?
Got about 10 minutes more of class.
Yeah. So
You guys, one more time. One more time. You can have more time, okay? Providing that you will be. Oh wow, it's you got the vertical man bug solved.
Yeah, maybe.
Hey, that's really cool. That's really cool. Yeah, okay, can you run it so I can see the guy move? Yeah, I'm pretty sure he'll move. Okay, so so you can as long as you will continue working on the movie. Yeah, that's really nice. Right, no flicker even, right? Even though we're clearing the screen, there's no flicker because everything happens so quickly on modern machines. You don't see a flicker. Technically, it's possible not to do this without clearing the screen because if you Google for ANSI codes to position the cursor, you'll actually see you know, the ANSI code /033 and 2J and all. You'll see there are lots of codes like that. Some of these codes will move the cursor to a specific place on screen. So you don't actually have to clear the whole screen to draw these things, but it's a pain to do that. That's why we did the clear and it's working quite nicely. So you know, I know we said we have to produce the whole movie by the end of class, but maybe it was too ambitious. But I would like to still see the whole movie. So if you can, you know what, let me make it more worthwhile for you. How about 10 extra credit question points for every single person who produces a movie, or or plays a significant part in the creation of a movie. You can even do the credit scene after the two people have bumped into each other, boing, and then you fade in, and the end. Not fade in. You can't do fade in. The end appears, and then you can have credits. Kate Larrick, Tim Bloom. Oh, you can all have the credits rolling up too. You can do that screen too, right? So you can do that entire thing. Maybe it's a 20-minute movie, a 20-second movie altogether. But you'll have all the participants' names using say Anthony, say Jaden, and Michael, and so on and so forth. All of them can be on screen, and they will all get, every one of you who participates in the credits, who gets credit, who's in the credit screen, will get 10 extra credit points. Okay, for 10 question extra credit points, it'll be added onto your questing scores. So I think I'll make that worthwhile. Just almost half of a quest. You seriously think about it, it's worth it, I think, right? So if you can, are you guys confident enough to produce a movie? Organize your own meeting times, coordinate Zoom or STEM Center times, get together maybe 2 or 3 hours over the next 3 days. But by the end of Sunday, certainly before next class on Tuesday, you should have a full-fledged movie, right? Along the way, if you're stuck, you should always feel free to ask me for help, right? There are, people in class who can help also. And hey, Anthony, your housing issues all sorted out now? Almost? Okay. All right. Okay. Well, anyway, so once that's done, you should also dive in and take a greater part in the movie production. So I would like to see that in the next 4 days, right? And everybody who's part of that movie will get 10 extra credit points for your questing scores. And I'll add them on into Canvas, okay, directly. So you don't have to. Oh, by the way, you need to fix a typo. Diagonal, D-I-A-G-N. Yeah, there you go. Yeah, the other one also had a comment. Yeah, but yeah, that's fine. You can fix it later. So can you guys do this? So I see that you have the man moving. You need to adjust, I think, right? You can play around. You'll find out when you do the fallen man. You'll find the aspect ratio of the screen throws you off, because right now the man has a narrow head, right? More tall than wide head. But when you flip him over, I think you'll find that he'll be wider or something like that. The aspect ratio will throw things off, but you got to figure that out. It's easy, right? You don't have to figure it out. Okay, when the man's fallen over, maybe his proportions are all screwed up, right? Maybe his head is bashed up or something like that. So you don't have to fiddle with the aspect ratio, but certainly get the movie going. Okay. And if you want to, and I can tell you, if you want to make a sound, okay, put /A. When you say, right, say something on screen, you just say /A. Yeah, I think you can say /A. Oh no, don't do /A for now. Okay, so leave it alone. All right, so yeah, let's leave the audio effects out for now. Are you guys confident with over the next 3 days together as a team, all of you produce that movie where 2 people come running towards each other and they bump into each other and one of them falls down? And in fact, if you want to take that to the next level, give one of the people slightly higher velocity than the other, right? Meaning the left person jumps 2 dots at a time. The right person only jumps 1 dot at a time, something like that. Okay. And when they meet, you can make sure that the person who's moving faster is the winner and the person who's moving slower is the one that falls down. So the decisions like that, you can make those decisions. Or you can just say both of them move towards each other at the same velocity, but when they hit each other, I'm going to toss a coin, random number between 0 and 1, and say, if it's a random number determines which person is going to fall down. So you never know until the very last minute. So all of those things will open up for you. If you're stuck, I am absolutely happy to jump in anytime, even over the weekend, and guide you guys, provided you have a little group, right? At least 3 or 4 people working on getting that movie together, right? And I'll show you how to make the credits scene at the end too if you are stuck. And I think it'll be really cool. Okay. Are you guys happy? Was this a useful class? Did you guys do some cool stuff? Great. Thank you, Kate. Okay. I know we put you through a lot today, with Xcode and terminal and everything else, but fortunately you were right on top of all of those things, and we managed to get something cool happen on screen. So grateful to you for that. And Michael and Tim and Chongwen, I heard you all, okay, helping out and fixing the bug, which is a big thing, by the way, okay? Because, you know, as it is, the program is not trivial, right? It's like over 100 lines. And if you have a bug, just finding out where the bug is and trying to figure, you know, what's going on and fixing it, that's actually a major thing, okay? It's not just, CS2A should not just be about looking at code and figuring out what it is and putting the answer down. It should be about trying to figure out where the problem is, right? And not a problem that I constructed and threw at you. This is a problem that you came out of your own code, which is really going to be all of the problems that you encounter in future is bugs in your own code. How do you fix it? And we had a situation exactly like that, and you fixed it too. I'm very happy to see that. So is that good enough for today? Can we meet on Tuesday? And on Tuesday, by Tuesday, I hope all of you on screen at least would have got 10 extra credit points for this movie that you're going to produce. Okay, so I will look forward to that. If you don't have any other questions for me, we can call it a day. Have a good weekend, hopefully working on this code. Okay, and I will see you again on Tuesday. Yes. Okay. Thank you all. Thank you all so much. Thank you for your patience, Kate, and everybody. And I will see you. And I look forward to the movie.
Thank you, Professor.
Bye.
Bye.
Yeah, Jaden, go ahead.
No, I was saying bye.
Oh, all right. Bye. Well, you raise your hand. I don't know if you know. Say,
Yeah, goodbye.
all right. See you later. Bye.